as well. Just give me a minute. Meanwhile, anybody want to share any updates with respect to the CNCF, KubeCon, or cloud native in general? Anything interesting you have seen in the ecosystem? I think all the announcements are going to come in the KubeCon, and people are waiting for that. Um, so yeah, let me just share my screen. Okay, great. Hope you all can see this. Yeah. Service mesh, that's what we're going to cover. Any of you has have used any kind of service mesh before? Any of you has tried? I think I remember Mohammed saying that he tried Contour, right?
Uh, Service mesh, I tried Istio
Istio.
service mesh. Yes.
Who was saying Contour? And somebody was saying, okay, that was
Yeah, I used Contour is more like ingress controller.
Ingress. Okay,
Yeah, ingress controller.
okay. Anybody has had the chance to play with Traffic?
Sorry, what's the question? Traffic. I just heard the last word. Traffic. What?
Yes, Traffic is a tool which is pretty good actually, right? So I was trying to set up like um, one machine with all the different kind of softwares, and Traffic just made it too easy. Like I was just using bunch of Docker containers and then using Traffic for that, and it just worked out. And it is a first of all proxy, but it can behave as a service mesh as well. So I believe so. So at least the API gateway for sure. So that was pretty good. Okay. So Istio, anybody else have used Cilium cluster mesh or something like that?
No, just play around with this Istio
Okay.
repository that they have, installing it and doing the labs.
The book info one,
And
yeah.
yeah,
Correct.
not
Yeah.
in production though.
Okay. Okay. So has anybody heard a use case of that? The service mesh we're going to look at in terms of containers today, right? But service mesh can also expand with respect to the VMs and the containers as well, right? So it's not that service mesh is a concept where it is applied only for containers. We can actually use service mesh to connect the VMs and the containers. That's something which we look at what service mesh is today, but I'm just saying that just don't look at from a perspective of Kubernetes. We can use the service mesh with containers and VMs. And that is how people are even migrating their workload to Kubernetes as well. So basically, people will spin up a basic Kubernetes cluster when they are migrating to Kubernetes, right? And they'll have the remaining stuff on the VMs. But with the Hello Service Mesh, they can connect, correct? And that way, it would kind of help them migrate to Kubernetes over time. That is one of the use case which I have seen in a couple of my clients' environments. That's what they have done there. Okay. So being said that, let's just try to kind of jump into service mesh. So I'm just trying to get if my iPad is not charged. So I'll not have my notes actually. Sorry, yes. Generally I have my notes there, but hopefully I would be able to still kind of cover from this PDF itself. Um, okay, service mesh um, are these are not a new concept as what we may know, right? That they're not so new concepts. They have been there, but the only thing was that they were implemented for a specific language or the specific use cases earlier. Now, before I even go into this particular concept of service mesh, so if you look at when we deploy our microservices, uh, can you mute, please, Abdul? So when we deploy these microservices, the microservices would have different endpoints. So, for example, in case of e-commerce, right, we have payment, orders, logistic, and so on, right? So these can be different microservices, and uh, and they can be deployed in different environments, right? But for example, when we are connecting to, let's say I am on the order service and I want to go to payments, so I may just say slash payments. But now that slash payment service may not be available in the next hop, right? It may be on a different cloud. As I said, it can be on VMs as well, right? Now, when the network would come into picture, right, we don't know what's going to happen, correct? So now, for example, as I said, that like payment may be on different cluster altogether, different internet or different network altogether, right? So what can happen is it's a different network. Our uh, network can be choked for some reason, right? Or there can be a packet drop for some reason. Now, considering all that, when everything is not available just in next hop, we can have these kind of problems, right? Like, can I enable automatic retry? So, for example, let's say today, right now we're connected to the payment service, and payment is not available for few seconds. Should I go and try for the second time or not? Who would decide that? Correct. Now, either I can put that logic in my application saying that I'm going to connect to the payment not once, twice, thrice. Or now if I want to change, let's say I want to say, try to connect 5 times. Now, if you hard coded that particular 3 time reconnect within an application, you cannot do this 5 time connection, correct? Similarly, circuit breaking, for example, if something is broken, if you keep checking the same connection, it's going to become a problem, correct? So what we do is we break the circuit. So for example, if we see that given point is becoming bottleneck, I may just discard all the connections. That's circuit breaking there, right? So now that is what the difference you can see with respect to the regular service object what we have on Kubernetes, correct, or in general, and why we need these kind of things, right? So if you understand this thing, we would be able to kind of understand, kind of get maybe make more sense of it, right? So what happened is all of these companies, Twitter, Netflix, and so on, so they tried to build the tooling earlier as well, and uh, and then they have done for a specific language or specific use case. For example, Netflix developed this Hystrix, right? And that is only for Java application. Now, if your application is not Java, you can't use it, correct? So that is the challenge what people faced. That now, as we deploy microservices, they can be on different type of language would have been used there, right? Python, Java, Go, and so on, right? So how would you basically implement a similar feature? And that is what happened is we came up with the concept of service mesh. So the idea there is now as everything deployed in the container, right? And as you know that we have a pod as a concept of Kubernetes, and pod can have one or more containers, right? So there can be one app and there can be a secondary container which can behave as a proxy, and that proxy can implement all of the features what we're looking here, correct? And that is what service mesh is typically implemented, but there are now other ways of doing it as well, correct? So we'll kind of try to come back on that topic again. So so routing, load balancing, telemetry, other capabilities are built into the proxy. That is what is kind of I was mentioning. So um, hope all of you got the idea, right? What is the sidecar container and how it is implemented, right? So I believe there would be a picture of it somewhere. Mhm. This is the old version of this, but yeah, I just try to answer it here a bit. So what's happening here is we have a pod. In this pod, we have our main application container and app container, and then we deploy a sidecar container. And this sidecar container basically implements those features I was mentioning earlier, like let's say implementing the retries, right? Implementing the secure connection between two endpoints. So, for example, when I say when this particular pod communicate to this particular pod, always the connection need to be in the TLS connection. secure connection. So all of these things are now implemented by these proxies, correct? So we are not changing our application code. We just kind of add this proxy along with each pod, and then we control these pods via some means. So as you can see here, there is this particular proxy which is sitting in front of each application. We would be having some kind of a control plane which can program these proxies on the fly. So what we are saying is, if the traffic is going from this pod to this pod, I want to add 2 millisecond delay, for example, correct? So all of these things can be programmed on the fly. So the proxy which were there earlier, like for example Nginx and so on, right? Those proxies are not built for this purpose, right? Because generally those proxies require the reload part of it. So if we change something, it require reload kind of a thing. But here we don't want to reload things, which you want to kind of apply things on the fly, correct? And then you want to program these proxies on the fly as well. And that is where we need the specialized proxy, which is built for this purpose only. Anything you want to add or any questions here? Okay, great. So let me kind of come back to it. Now I'll just go back a bit. So hopefully that makes sense, right? We need to implement routing, security, and observability. These are the 3 pillars or 3 things which you want to have within our environment. And service mesh can help us in doing that. Now, what example, it kind of what point the author mentioned in this particular part is that when the service mesh came, everybody wanted to use service mesh. I would use Istio for everything, but it can be an overkill, right? Because as we just saw, right? First of all, adding a sidecar container along with each application would require some additional resources, and managing them can become a challenge. So first of all, the company need to really figure out, or the team really need to kind of be sure that they want to use service mesh for sure. That's their requirement. They are not just kind of going and getting service mesh just because shiny object there, right? So first of all, you need to understand why service mesh is there. So they kind of made a joke here, right? We want to have a service mesh because we need everything it provides. They said 12 months later, the only feature they were using the ingress. Correct? Now, what's the point? Correct? Now, if you don't need the features, why would you use service mesh at all? For ingress, we have the ingress as available, right? The engineers talked about, and traffic and other stuff as well, right? So we should be first figuring out, do we really need that? And only then we should kind of go and take that up. Now, similar to the different interfaces we have, like containers, runtime interface, networking, CNI interface, we have similar SMI or service mesh interface. Now, to be honest, I have not seen much. First of all, this service mesh interface resides outside the Kubernetes ecosystem per se. Like, for example, what they were mentioning is um, the the community though built it, but it is kind of not as tied to the Kubernetes thing. So you can choose to use SMI or not to use. I'm not too sure about that, but they have given the kind of a say the kind of a say very um, ideal use case that if everything works perfectly fine, right? If I have an interface which can connect with Istio, Linkerd, Contour, or whatever it is there, right? If we can build something, a common interface, what we can do is we can kind of configure the kind of a say network or whatever traffic we have in certain ways, right? Like for example, we can have this kind as traffic split, and it can split the traffic between V1 and V2, 70-30% kind of a thing, right? Now, considering that, I'm just going to write this behind the scene. If I use SMI, it would work uh, as it is, irrespective of the service mesh we have behind the scene. But I think this is a bit challenging to achieve, and I'm not sure that what is the current status of SMI. SMI, if somebody knows that, you can tell the details about it. But there's an ideal use case here. For example, like the second example they are saying is, again, this is like a network policy here, allow or not allow connection from a given endpoints. So even that is part of the SMI there. So, so you can check out what is the current state of SMI. Can you just check what is the current state of SMI, whether it is implemented or not implemented?
It's basically archived. They've kind of
Archived.
yeah decided not to continue it anymore.
Correct, correct. Yeah, that's what I'm saying. It's not because it's very difficult to kind of implement by with different providers behind the scene, right? To kind of come them and agree on this. It's a bit challenging because I think CNI um, and that CRI, right? The network part and the runtime, because they are very low level, right? They are very fundamental. But here they are kind of sitting at the top level, and of course they have different algorithms and so on. So it's very difficult to kind of do that. So SMI, I think, as I said, is archived because this book is a bit old, so we need to kind of go and check what the current status of it. So SMI is anyway archived, and then we know that why it has done so. I think we talked about last time this part already, right? I'm not too sure. Yeah. Okay.
Yeah, we did.
Yeah, I think that's what is like, coming to ask the SMI thing, right? Yeah. Okay, but anyway, let's come to this. Next part here is the proxy, right? So the Envoy proxy is something which is kind of built for the cloud native ecosystem per se, and that can basically support what you call say hot reload. For example, even traffic is going, and I can change the configuration of it. Correct, and that is what the Envoy proxy can do. Okay, before I go further, anybody has configured Envoy proxy on its own?
I just played around with Envoy a while back, but this particular use case, Nipendra, that you also mentioned last time, I wanted to ask you, but I guess we were out of time. So
Mhm.
even if I'm using, let's say, Nginx ingress controller,
Mhm.
that provides me with hot reload of configuration, right? If I make some changes to, let's say, ingress object,
Hmm.
it uses some kind of Lua script that I remember reading,
Hmm.
and it
Correct,
does a
correct.
hot reload of. So does it also use Envoy behind the scenes?
No, and it does not use Envoy and Nginx for sure. It does not use Envoy for sure. It's a
Okay,
different implementation altogether.
okay.
So yeah. So Envoy does not do that. So if I kind of let's see if I kind of get it. Okay. So I think I can try to explain this example here, and let me just try to. I'll just reshare my screen in a minute. I'll just try to get the other data as well of Envoy.
Sure.
Just trying to get one of its configuration. Wow, community training. They're all given from here. Config examples are here. Yeah, let me reshare my screen. Yeah. Okay. So if I go and look at one of the example of Envoy, right? So this is the Envoy repository, and and if I look at one of the simple example here, let me just check which one would be the simpler. I think for proxy would be the simplest one. Yeah. So what you see here is this is how the Envoy configuration file looks like. Correct. Let me see if there is much more simpler one other than this. Just check this, otherwise I'll go back to the other one. It is simplistic there. So now this is what you see is one of the configuration of the envoy configuration here. So this is a envoy.yml, and this would be kind of given into the proxy, right? So we have a proxy which we are configuring, and this proxy, whatever we are having, this is the configuration which we have, and this we can program on the fly as well. So now if I try to kind of come back here and look at here, right? So you see here, right? These are LDS, RDS, CDS, and EDS. So I think the way they pronounce it, just go and check at discovery service, right? So these can be, that's why we call it as XDS, right? Because these are listeners, routers, clusters, endpoints, right? So listeners, routers, cluster, and endpoints. This is how they are being given, right? So now, if you look at the configuration here, I'll go back. So this is the configuration. You can see listeners. Then the listeners would have some filter chains further, and then you'll have these routers, and then you have the clusters, and then you have the endpoints. Correct? This is how you have to read this envoy configuration file. They are like chain, right? So so you go to one step, find the next step, and then in a given step you can perform certain operation as well. Correct? So that is how I'm not an expert. I'm trying to kind of do whatever I can do best here. As you can see
This
here,
looks like an expanded version of the virtual service that we create in Istio. So if I look at line number 30 onwards, like 30 to 35,
yeah,
whatever.
correct.
Yeah.
That's what's happening behind the scene, right?
Yeah. So it basically translates our Istio virtual service into something like this, probably.
Correct. Yes, that's what going to happen eventually.
Okay.
So now if you look at here, this is the first is listener, right? So on which particular port number um, our STU is our not STU and was going to listen on, right? So we can say listen on port 80. Like in this case, we are saying listen on port 10,000. So it can be anything. And there can be multiple listeners as well. So listener 0, we can have listeners as well. So again, this is an array. So as you know, under the thing, we can have different listeners as well. Now, under that, we have different filters. Now, these filters can be, we can think of, they are HTTP filters, and there can be other filters as well. Like here, we are saying this the HTTP router here. So we are working out with the HTTP filters, and we can do different things with respect to the given filter type. I'm not going too much of detail of that, but you can see that. Or if I want to kind of go back and look at, so if I look at envoy, see filters. So you will find different filters here, as you can telling, right? There can be different filters can be there, right? Which you can apply one after another as well, right? So for example, there can be filter for AWS Lambda, bandwidth limiting, right? So for example, if you want to limit the traffic when the kind of a say, let's see here. Yeah, there's a filter here, right? So when I want to go over this particular flow, right? I want to add this 0.1 second of kind of a say delay on that, correct? Or whatever this bandwidth, whatever it is, right? I'm just trying to convey that. So you can add these filters as you would wish, one after another. So that is how you can build the flow, right, of your packet which is going through, correct? So once we have figured out the listeners, we'll go to the routers, and here you can see the routers. We say service name. So now with this service, we would actually go to our cluster service or whatever service we have connection there, right? So this can be your, I believe this can be your regular Kubernetes service. And from there, it would go to the pods what you have. So again, whatever the endpoints here, they would be mentioned here. That is how the flow of these things look like. Hope this makes sense, right? And this is how Envoy is dynamically configured as you kind of change it. So for example, if I have to, as I discussed, right, if I want to implement something, right? So for example, um, let's see, fault injection, for example, right? So if I have to implement the fault injection in between the things, I can use this filter to implement the delay, right? For example, mentioned here, right? So I can keep adding these filters and get those features as I want. So this is how the envoy works. So you have filters and you apply them filters, and through that the traffic would flow on. Make sense?
Yeah.
Yeah. Okay, great.
So this
Um,
Envoy basically looks like something which is not native to Kubernetes. It's more of
yes,
a generic
it's a generic solution. Yes, and I said that
solution.
envoy, you don't require Kubernetes, or you don't require envoy to run Kubernetes, right? So if you look at the envoy use cases, right, you'll see it has bunch of other use cases as well, other than just Kubernetes. It is very generic one. So it is not only built for Kubernetes. It's just like for like you kind of flow through this what you would say, the network, and then you can configure as you would wish.
For microservices,
Yes,
basically.
correct.
Yeah, connecting microservices, proxy for microservices.
It can be done for VM also, right? So Microsoft is perfectly fine, but as I said, it can be done for VMs as well. So you can even have then see again, if you look at what it has, just a pointer, right? Like from here, go to further, right? That's all. So it's a whatever, like you are reading on a network endpoint and then you follow through. So it may not be the microservice, but it can be VMs, even I think your Lambda functions also, everything it can cover. Yeah. Okay.
So has anyone used a hybrid setup where you have this Envoy running on for a bunch of microservices on a VM plus also Kubernetes based workloads? Because the
I
question
told
that
you
I've
with the STO, I have definitely seen it. With the STO, which implements Envoy, it was a use case for sure. Because
okay.
you are when you want to migrate, so that is the case when Envoy did not came up with their own proxy. So earlier, Envoy did not have their own service mesh, sorry, per se. But then I think they made the entire service mesh also available along with it.
Mhm.
So earlier it was only the proxy, but then they came with, I don't know what the status right now, but in between they also launched Envoy Service Mesh, which I don't see here. They have kind of, I think, they said let's just move on from here and work it
Possible.
with these guys. So because
Mhm.
they are your own challenges, right, and so on. But yeah,
Now, I was just thinking, how would the service discovery work in that case? Especially if, let's say I'm running something on a VM.
console,
How would kubedns based
console, console, console,
console?
console, console,
Okay.
and I think that's what the use case would be.
Okay. So I guess HCD if not console.
Yes, whatever, yeah, whatever it is, right? So
Some kind
there
of key
would be
value store.
something, there should be something, right, that which is going to help you. So it is there, right? So, and what was the service mesh? So I think there are multiple ways of achieving that.
So if you have your workload set up on Kubernetes, you don't have a hybrid workload.
Hmm.
Do you see any use case, Nipendra, where one should kind of consider using Envoy directly rather than using some kind of a framework on top of it like Istio?
Hmm. So there will be some reason why they have built the service mesh in between, but I don't know because you need a way to control it for sure. And even with the Envoy proxy service mesh as well, right?
Mm-hmm.
They would have done something like that, right? Because you require a control plane to do it, right?
I didn't
The
get that.
control plane, you cannot do it, right? So there would be something, something would be there, right? So I don't think they are kind of now open source and service proxy. Kind of mentioning it for sure.
Istio uses Envoy proxy.
That is for sure, yes.
Yeah,
So the question is,
and also Glue Mesh, which also use Envoy. I don't know if Linkerd is still using Envoy. Linkerd has made some changes or a new version which is using Rust instead of it was using Golang. I
Correct.
don't know if it's still using Envoy proxy or not. But basically, all the service meshes, most of them they use Envoy proxy.
Yeah, correct. So they try to build it earlier, but I don't see anything on the site as well, right? So earlier they had this service mesh as a and from the envoy itself, but I don't see anything right now. So I don't see that. I mean, there might not be a good use case of having a envoy service mesh by itself. But yeah, I may be wrong. So, but I don't see on the site for sure right now. Correct? At least I can see. If you can find out some reference to it, you can tell us. Yeah.
Sure.
Okay. Fine. So now the point is that like this is the old version of as you can see, this is the old version of this is not the new version of Istio. So if I go to the Istio website, we'll see its new architecture. Like this is the architecture what they have, right? So earlier this control plane was kind of divided into different part, right? Gale, Pilot, and Citadel, they were different microservices, but then they by themselves said that let's just make it a microservice, monolith service after that. So earlier in the STOD, these were microservices, but then they kind of get rid of them and they made a simple monolith-based STOD control plane. And then this is the remaining part, right? So that you have these pods, each pod runs a proxy, and the control plane configures the proxies at the as the requirement is there. That is how it is there. Correct. So as you can see here, discovery, configuration, certificate. So all of these things are happening. So you discover all the pods which are running, then you configure them, and of course you enable the communication between them, the TLS-based communication between them. Correct. And then you can get the metrics data, observability data from the envoy to the control plane, and to kind of visualize that later for the later part. So this is one approach where you are deploying the service mesh or the proxy with each container. Now, I believe all of you have heard about Cilium. We talked about it earlier as well, right? Now with Cilium, work in a different way. So Cilium, so if you look at in this particular case, we are deploying the proxy per container or per pod. So if you have 100 pods and if you configured uh, service mesh, then you are running 100 pods minimum additional to those primary applications what you may be having, correct? So this basically added uh, more resources to the system, and of course it can be much more slower if you don't use service mesh, correct? So there are a few use cases where there are service mesh like Steve can become slower or it can add a substantial overhead, and the Cilium service mesh, right, or Cilium cluster mesh, if I look at, yeah, yeah. So if you look at here, so I don't know which particular diagram I should explain with. I just get some images from here. Not this one. Yeah, so I think this may be okay now. Cilium agent. Okay, I should have got this diagram earlier. Okay, but the point I'm trying to make here is so Cilium implements the service mesh in a different way. So rather than deploying the proxies with each of your pod, like as you can see here, there are separate pods are there. Now these pods are not implementing the proxy on its own, correct? What are there is they're going to be envoy proxy, but it would not be running per application, it would be running per node kind of a concept there. So other than deploying the proxies per pod, it would deploy at per node level or the less number of proxies for sure. And that makes Cilium mesh as another good alternative there. So as you know, Cilium works on ePBF. ePBF anyway much more faster than your regular CNI plugins what you have. And then they have taken the concept further where they are saying that we'll not go with per sidecar container to each pod. You would maybe add a envoy proxy per node, and that should be able to do the remaining stuff for us. Correct? So that is how the Cilium is doing. But again, that's again not part of this book. But I'm just saying that if you go further, look at, you will see that there's a comparison details as well. That if we can do ePBF based service mesh, it can be much more faster. But there are some, I think, feature set which are not implemented or they are yet to implement in the other way of service mesh in which we are doing per node based agent other than per pod. So that's something which is I need to still explore there.
I believe even Istio has announced like ambient mesh last year sometime, and
Yeah,
they are
yeah.
also kind of working on this sidecarless eBPF
They
based,
have to. They have
proxy.
to, right? Because
Yeah,
otherwise they lose the thing, right? And even glue guys also move to EPBF, something like that there, right?
yeah.
So earlier there was thing that okay, no, EPBF may not be there, but EPBF is now there, the default choice, right? So people don't have much options there. Okay. So what can happen is now when you have to insert these proxies, one option is you can implement or insert these proxies manually. That's one. Or what we can do is we can configure some kind of way by which as soon as I create the pod, these proxies get inserted automatically. So what happens is for a given namespace, if I want to enable the proxy is there, right? So if I add a label or annotation to each namespace, right? And if the namespace has annotation, automatically all the pods, when you created the namespace, it would insert a proxy for you. That is how it has been done. So you can implement as a init container, or it can run as a another regular sidecar container. This are sorry, it would run as a sidecar container only. This is something else, I believe. This is like how do I set up the given thing, right? So because creating the pod one thing, the container one thing, you still need to kind of go and modify your firewall IP table. That's what mentioned here. That as you deploy the sidecar container, before that you will kind of modify some of these IP table rule as well. That is what is mentioned here. Okay. So then we can enable the TLS communication between the two pods as we want to connect them. So we can enable this MTLS mode strict. This basically makes sure that the communication between the pods always happen via the TLS connection, which means the connection between the pods are also encrypted. So generally, pod-to-pod communication is not encrypted, but if I enable this feature, it would be encrypted all the time. Correct? Okay.
In
Now,
this in this in this MTLS thing, Nitendra, sorry, I have one more
yeah, go
question
ahead.
I had when I was reading this.
Mhm.
So this looks like we have enabled MTLS for all the services in namespace Istio system, right?
Mhm.
Or is this YAML for a particular service? Like, what does this apply to?
No, this is applied to. So, for example, you can enforce the cluster level. Okay, this is for the cluster level, right?
Okay.
So if we enable this, all the pods to pod communication would happen via this way.
Okay, so entire cluster is now basically MTLS enabled. So everything that
So
has Istio with it will do
correct,
MTLS. But
correct.
what if I have only one service running in the cluster? Uh, what does MTLS mean in that case, or
It does
what would
not
happen?
work in that case. It would fall down. It would fall back to the origin, the other one. But because if you put the strict mode here, right, then it become a problem. So there is a strict mode and there is a whatever the kind of a easy mode. I don't know what is the mode name it's called. So in this case, if you enable this strict mode, it basically if both the endpoints are enabled with NY, no problem at all. Correct.
Mm-hmm.
But the problem can come where a pod which has the NY attached to it talk to the pod which doesn't have the NY attached to it. Correct. What will happen
Right,
in this case?
right.
So
Probably yes. That could be an example.
that would be depending on this mode actually. So if mode is strict, it's going to fail. But if there's other mode name, I don't know what that is called, easy or whatever it is, right? In that case, it would fall back to the non-TLS based connection.
I was just trying to visualize this, and probably I was thinking, where does this MTLS initiate and where does it terminate? So is it from my service, my application to the
Pod to
Istio
pod,
proxy?
pod to pod.
Yeah, from even from pod, let's say I have one Java application and one Ruby application, right? And
Hmm.
both of these applications have sidecar proxies with them, right?
Hmm.
Istio sidecar proxies. So this MTLS terminates at the sidecar proxy, or it,
Yes,
it
proxy
terminates
only.
at my
Proxy.
application.
No, no,
It terminates
proxy,
at the
proxy,
proxy,
proxy. Your app is not bothered about it, right?
right?
Proxies are bothered about
Right. So from proxy to app, it would still be non-TLS. It would be
it.
HTTP,
Yes, correct, correct.
but it's within the same pod, so pretty
Yeah,
local, I
that is
would say.
fine. That is fine.
Yeah. Okay.
Correct. But pod to
Okay.
pod, which basically when you enable proxy,
Mhm.
those proxy also talks, right? And then there should be that one.
Okay. Okay.
Okay, great. So now, if I talk about in terms of Istio, right, it implements the concept of a virtual service and a destination rule. So now, if I look at, so the way you can look at here is, we'll look at in the reverse order. So in the destination rule, we define the service or we define the destination rules by different subsets. So what do I mean by subset? So for example, let me actually get this example, book info. Yeah, this is the application here. The book info application is there. So now this is, you can see we have Python, Java, Node, Ruby. And for the Java app, for the reviews, we have different versions here, right? V1, V2, V3. So again, though it is called as a the review service, but it can be subdivided into three parts, right? V1, which has no star. So this is an example of a book info app. So what happens is if you open this app, it is going to give you book reviews. And for the reviews, at one point it will give no stars. It can give black stars or red star, depending on which version of the app you connect with. Correct? So now if I kind of go back to this example here, you can see here under destination rule, we are giving these additional additional labels here, right? So though we have a service, but service called reviews, but even reviews can have subparts to it. So think about these pods are going to have two labels, right? One is, think about one label is app reviews, and second label is version V1, V2, or V3. Correct? So typically, when I connect to the Kubernetes service, I would say where app is equal to review. I'll connect to any one of these at random. Correct? That's what we do. But if I subdivide further, I can say now versioning as well, right? So now I'm saying within the flight service, I would have further versioning here, V1 and V2. Correct? That is what is being defined here. Correct? So I'm kind of creating these subsets. And once I create these subsets here, I can use them inside my virtual service concept. As you can see here now, I'm saying for the flight virtual service, you would send 90% traffic to the version V1 and 10% to V2. Correct? Does it make sense, guys?
Yeah.
Yes, it does.
Okay.
This basically is the canary thing, right? That we usually do.
Yeah, basically you have to change the version. We can keep changing the pointer here and then keep modifying it. That's all.
Yeah.
Okay, all good? Fine.
Actually, it's more easy to implement that for canary deployment than the regular way we implement it in Kubernetes ingress and so on. This is one resource to have the split traffic and so.
Yeah,
Yeah.
correct. The point there is, so for example, if I look at the typical Kubernetes way, right, that number of percentage works in terms of pod count, correct? So think about, you create two different deployments, right? And then depending on the pod count you have, the traffic would go accordingly, correct? Hope you're getting my point, right?
Yes.
So, but here it does not depend on the pod count, correct? That's a major difference if you look at, if you're implementing by the STOs or other service mesh way.
Yeah.
Request count, I guess. Number of requests, 90% to V1 and 10% to V2.
Correct. So this does not mean that there are 9 pods running for this on one pod running for this. No. Correct. In the just a regular Kubernetes based service, you'll require to run 10 pods of V2, 1 pod of V1. But here you can have overall maybe 3 pods running, 2 of V1 and 1 of V2. And that can do your 90 and 10 percentage. Correct.
Yeah.
Let's move on. So this again, I think given it how much traffic has gone through. And this is already talked about already. I think we did talk about it. A sidecar proxy is already done. And node proxy is there, right? Node proxies. This is how you are doing with the Cilium mesh kind of a thing. Correct. Then what is the main point? Adopting it. Yeah. So basically, first of all, figure out why do you need it. Correct. What exactly the feature you're looking for, right? If you're not looking for MTLS, you're not looking for the circuit breaking and other stuff, maybe stick with the ingress, or you should figure out what exactly you're looking for, correct? And then you should deploy to the new existing. So I think they mentioned to the new cluster altogether, I believe so. Yeah, I think the idea is that you should try to do it in the remaining one and then do it. New one, sorry. Handling upgrades, what was it point here? I just like have a strategy to place. And you should have some additional resources available for you so that when you're deploying the this mesh, that is taken into account. Um, So you can either bring your own CA, or you can the CA or whatever the CA STO have, that can also use to communicate. Right. So build this mutual TLS based on the TLS or the CA what has been configured by STO. That will take care of it. You can also configure the multi-tier service mesh as well. Correct. So yeah, that's about it. Any thoughts? Any comments here?
The CA certificate, can I generate it myself, or it's generated? It's only generated by STO.
Can you come again? Sorry, I'll just
The CA certificate for MTLS.
Mhm.
Yeah, can I create one, generate one by myself, or I should
It's a
follow the
lot of
one?
overhead if you do it that way, because see, this is going to be per pods, right? And the idea is that you just want to make sure that it is they're able to verify by themselves, correct? Rather than try to get it somewhere outside, right? So this one, before able to leverage MTLS feature, you must establish manage strategy while the Yeah, basically that you can do it for sure, but there is no, you should not bother about it getting from the outside or your own public one, right? Because this is internal to the cluster, and within the cluster, if they can communicate, right? And if they can manage by themselves, right? Somebody signs, somebody verifies. Why do you want to bring it outside? You can, but you should not do it. I mean, it's just an additional work for you.
Okay.
Okay. But it's just an overwork. That's what I would say. Okay, so with that, we have the next chapter, secret management. This, of course, will start in the next session. So Abdul is going to take the lead on this particular chapter, right, Abdul?
Yeah, sure. There are a couple of hands-on things as well, which probably I'll show during the next session. Yeah.
That would be good. Nice, nice, good. So yeah, so I think we'll finish. This would be how many pages? I don't know. This is
I think
185.
should take maximum 2 sessions
Yeah, I
from
think so.
what I think. Yeah, depends on what kind of interaction happens, right? But 2 sessions is what I'm looking at.
Okay, sounds good.
Yeah.
Yeah, and anybody else want to volunteer for the next chapter so that we can prepare for the time? If anybody want to volunteer, again, it's like we can. It's like that. You just take the lead and we all come together. No problem. I'll be there. I'll be definitely reading the given chapter and give my pointers. But as a group, right? If we take the responsibility, one take the responsibility of at least finishing the entire chapter, coming up with and we'll discuss about it, right? Anybody want to take a call, decide or
I can try.
cool, Rahul? Nice. So, okay, so then I think we are good for the next two chapters. Of course, we'll be kind of discussing, and it's not that one person has to kind of take the entire session. We can always come and discuss. Okay, good. Rahul, did you join the other sessions? I'm not too sure, or maybe I just forgot to know.
No, this is my first session.
Okay, okay, great. Rahul, where are you based?
I'm based out of Toronto.
Toronto. Okay, nice.
Rahul is a bold man.
Okay, yes, first session, and then you can. Okay, that's good. No, no, it's good, good. I think that's how we'll kind of read more books much faster, right? That's the
Yep.
whole strategy, right? We are doing it for ourselves, right?
So I usually read books by myself, but this is kind of good, right? Like I can share my thoughts and then you can
Correct.
share yours as well.
Yes,
Yep.
yes. That's the whole idea. Okay, we are good then. I think we took some lead by thinking of whether we write a book or kind of us in notes about it, or we'll get a quiz. Anyone have any thought on that? I was thinking of creating a quiz actually. What do you guys think about it?
So you plan to do it midway, Nipendra, or like end of the book?
No, no, we'll just start creating the quiz as we kind of go over it. Like not right now. Maybe what we can do is, I think midway is also fine, right? What we can do is we can create a quiz as a together thing, right? So, for example, we have gone through I don't know, let's say 10 chapters, correct?
Mm-hmm.
And we'll try to create a quiz out of the chapters what we have read and give it to the public and see how they'll do it. Of course, we can do it ourselves as well, but
Sounds like a plan.
we can toss others as well. Now go and read the book if you can't answer these questions.
Yeah,
So,
sounds like a plan. Let's see. I mean, they can
yeah,
start
let's give
putting
it
some
a
stuff
shot.
together.
Maybe after 10th we'll kind of take a break, and in one
Yeah.
session we'll try to get our notes and try to build a quiz.
Yeah, that sounds more doable.
Yeah.
Yeah.
So after 10th chapter, we'll take a pause for a week and then just try to maybe just get our notes together and try to build a quiz and then give it to the public to take a shot. Yeah. Okay. Sounds good. Okay, then I'll see you guys next week. Any other points, any questions, let us know.
Yeah.
Thank you.
Okay. See you guys.
Thanks. Thanks,
Bye.
guys.
Thank
Thank you
you.
very
Bye
much.
bye.
Bye.
Thanks, people.